Hi, happy to connect again. Today we are going to learn Destination NAT. So sometimes we also call it as DNAT. So in this session, I will be focusing on Destination NAT. So first, I will brief you about the theory that what basically it is, why we use it, and then I will configure it on the Palo Alto firewall. I will configure one of the security policy and also one of the NAT rule I'm going to configure on Palo Alto Firewall. So for that, I have taken an EVNG lab setup and there I will be configuring that. So let's see that what the destination ad is basically. If I take the example just now, let's see, let me open my lab here. So this is my lab, which I'm going to demonstrate you. So if I just focus like what the source NAT is, let's say that you are a user that is an internal source, right? And if he wants to access any of the resources on the internet, it can be, let's say, our Google server, right? Then what is going to happen? It is private IP, like so this can be source IP address here, and the destination IP could be 50.50.50.10 like the destination server IP address, and that will be the destination, and that will be traveling from here 50.50.10. That is going to reach on our firewall, and here our source address will be changed, and it may take the IP address of the its interface or something else, right? So now it is entering to the public environment, so it will take some public IP address, and it means that its source IP address will be changed. It will be done from private to public. So if the source IP address is changing, then we call it as an source NAT. While if the scenario is reverse, like if you see here that the traffic is traveling from internal to untrust zone, means from our internal network to internet, or we can say internal to outside. While if the reverse traffic is coming, it means that any traffic which is coming from internet, like any user is there in the internet, and if he is trying to access any of the server which is on the organization in the DMZ zone, let's say this is a user which is having the source IP address as a 50.50.10, and he's trying to access any of the server here which is having this IP address. Then how is he going to access it? Right? The scenario is reverse now. Earlier we were talking about from internal or enterprise network to internet. Now the source is at the internet, and now he's trying to access any of the server which is on the DMZ. So this time what I'm going to use, I will give him a publicly hosted IP address. So that publicly hosted IP address could be some public IP address. In this scenario, I'm taking it as a 50.50.100 that will be hosted on a DNS, or like say, let's suppose this is an web server, right? Uh, so what we will be having in a DNS entry, let's say that could be our abc.com, means that you are hitting abc.com, and that abc.com is resolving to 50.50.50.100. It means that indirectly you are, or any user at the internet is trying to access this IP address and services on that. So I'm going to host this IP address on this firewall. Usually we also take it as a load balancer, and then it is happening, but just for the simplicity, I'm taking it as a firewall on the firewall. So this could be your virtual IP address. It may not be on the interface of this firewall. If you see it here, I have given the IP address of the interface is 50.50.50.1, right? There's nothing landing this IP address because it's still somewhere it is. Okay, so that's why we call it as a virtual IP, or we can also say as a floating IP. So if you that's why I'm saying that this is a Palo Alto firewall. If you just go to the FortiGate firewall, similar configuration if you are doing for the DNAT, there is a term as an VIP. We call it as an VIP or virtual IP. then only we configure it with this name exactly. But here in the Palo Alto, the name is not like that. But yeah, we are doing the same thing. So this is like a virtual IP. We have nothing configured, no interface with this IP address, but still this user will be hitting to the address 50.50.50.100. Okay. So now what is going to happen if the user here who is having the source IP address as 50.50.50.10, okay, and now he's hitting the destination IP address as 50.50.50.100, right? So just forget about the DNS part because that is happening in the backend, but we are not taking care of that as of now. So now our the traffic which is I'm hitting as the 50.50.50.100, there could be some internal routing here because that is like complex network in the internet, and anyhow we are going to redirect that traffic which is destined for 50.50.100 to this one. This is usually done by the BGP advertising, but I'm not going to take a class on that. Like we advertise that one that 50.50.50.100 is behind my firewall. So any traffic targeting to that, please send to this firewall. So that's how it is, but just forget about that as of now. Just anyhow, that traffic targeting to 50.50.50.100 is going to hit the firewall. That is just a networking behind that. How it is coming, just forget that part as of now. But anyhow, the traffic is reaching to this firewall. What is that source IP there? The source IP is this 50.50.10 and the destination is this one. What is going to happen on this firewall? Here, the NAT will be happening. What will be happening? It will be happening the destination NAT. Means we will be translating only the destination IP address, not the source IP address. What I'm going to do this time, because this server IP address is 10.1.100, that's why we are doing the destination NAT. Because our actual server is this one, not this virtual IP address. So I'm going to translate that destination from 50.50.50.100 to this one. So now our IP address will be, destination IP address will be 10.1.1.100, and we can keep the source IP address as it is, which is 50.50.50.100. All right. So this now IP packet with this source and destination IP address will be traveling further, and that will be reaching to this server. This server will take a request and it will reply it back because it is getting the response like request from here. It will reply back. So this time the destination IP address, whenever it is replying, whenever receiving, this will be the case. Whenever it is replying, the destination IP address will be 50.50.50.10 because it is targeting to this from where the request came. And this time the source IP address will be of this server 10.1.1.100. All right. Now this request will go back to our firewall. Here it will be having NAT translation table because it has translated for the destination NAT, and it will do the reverse thing. From here, when it is reaching, it will put again the destination IP address of this the 50.50.100, or I can say it here. The destination IP address will be 50.50.50.10, and the source IP address will be the virtual IP address to whom you were targeting earlier. It means that 50.50.50.100. Anytime whenever this user will be getting the reply, he will be thinking, I requested to 50.50.100. I'm getting the reply from 50.50.100, and he will never come to know that the actual server serving this request is having the IP address of 10.1.1.100. So that is the magic of our destination NAT, and that's why we configure it. Let's see quickly that how to configure it in the Palo Alto firewall. So this is my lab setup, and the configuration are same. There's no change in that. Whatever I have told you, like the IP addresses are same. So this from this IP address, I will be accessing the firewall using GUI, and this is my internet user who will be accessing the server having the 10.1.1.100. This switch I have taken just for the reference, and this zone, if I'm talking about, so this zone is in the untrust. Just note it down because I will erase it, but while I'm configuring, I will use this. And this interface is in the trust zone. Just these are just like nomenclature. You can put in the DMZ or something in the real environment. That is fine. So anyhow, this is like traffic will be coming from untrust to trust, or if you want, you can like configure a new interface and put them on the DMZ as well. Because usually the server hosted to the internet are put on the DMZ zone. So you can just do that. There's not a problem with that. So now let's just quickly switch on to our firewall and let's see the configuration. So this is my firewall. Let's go to dashboard here. So just forget about the policies which are already there because they are like for the old one. So just ignore them. Okay. And just let me revert the configuration if there are, or let me commit it. So that will be fine. It will just quickly take it some time. And I'm not sure that what the configuration it was there, but it was showing commit highlighted. So just thought to do it rather than messing up our configuration. So just clearing it up, what is happening. So the very first thing that I'm going to set up a new rule to allow from external to DMZ, right? So I'm setting a rule external to DMZ. All right. Source zone, because source, the user will be from untrust, they are coming from internet. And source address, I'm putting any because any user can come to us. We do not restrict the users. And the destination zone, I'm going to put as an untrust. And if the users are targeting IP address 50.50.100, then only it should be applicable because that is our floating IP address, or we can say the public IP address of the server. So this is the one thing, and remaining, let me show you the other configuration. Like action was allowed, so I think you are quite okay with the application and all. So they are just any and any. I have not changed anything to them, and action is allowed. Okay, that's fine. Another thing I have to, like the first thing I have been that I have allowed the communication from outside to inside. Another thing I'm going to do for the NAT. So I use this lab for the U-turn NAT as well. So that's why the old configuration are there. If you are not sure about the U-turn NAT, you can watch my previous video as well. And this is like for DNAT to DMZ. All right. And the original packet will be coming from untrust, and the destination zone, because both are in the untrust and untrust, so that's I'm again putting it to the untrust. Okay, because for the sake of internet user, they are in the same, like he's also targeting to the untrust zone. And the source address could be any, we don't want to mess up with the source address, any user can access it, right? So I'm putting it any. And if he's targeting to the address 50.50.100, that is our publicly hosted IP address, or we can say the virtual IP, then please what you do, please translate that packet. And I don't want to translate the source address, like there's two options. Either I can also do the source translation. So both the ways are possible. If you are quite interested, you can do that as well, but I'm not going to do that as of now. I will just translate the destination with that. If the s- target was 50.50.50.100, then please translate it to 10.1.1.100. Okay, and just hit enter and just commit it. Okay, but before that, let me show you that what is the current situation now. And this is like user, internet user, what I was talking about. If I show you the IP, so this is the IP address right now, and if I ping it, that 50.50.100, that is not going to work. It will give you a request timed out because I have not committed it, right? So host is not reachable. Okay, no worries. If it is not reachable, that's also fine. And let me commit it now, the configuration on the firewall. So translation, that is for the, okay, that's fine. Here we go. Now let's check it out. What is happening now? Okay, so I think there's a problem with the sequence number. So let me do it from top to bottom. That's how. And same is for the security policy. Security policy is I think fine. 10 dot. Oh no, for the external, if uh, it is targeting to the source 10.1.1.0 and the address is 50.50.50.100. I think it should be working, but let me put on the top. Let's see what is going to happen. Okay, I think I missed the zone. They are wrong. They should be traffic should be coming from untrust to trust. Hold on, just let me change that. Here the destination will be untrust. Add trust. Sometimes I do just mistakes and you learn it. So I just like feel good. Okay, I did the mistake. That's really good thing, right? So if I don't do the mistakes, you don't learn that. Okay, that can also be done. Like if I do mistakes, you feel it. Okay, that's how it is not working, right? So I do mistake, but you actually learn it. So uh, I lost my time, but actually it's good for you. Okay, let's see now. How is it going to happen this time? And here we go. So this time, if you see the reply we are getting from 50.50.50.100, that is fine. Let's see on the server that what is happening. If you see that the server, the source is 10.1.1.100, that is fine. And the destination is 50.50.50.10, right? So like for the from this server, the destination is 50.50.50.10. And if you check it here, like on the internet user on this machine, you will see that the reply is coming from 50.50.50.100. But actually, you see that the request was sent by this server. There's nothing like no interface that 50.50.100. So this is like one thing that we did not do the source NAT, but at the same time, we can also configure the source NAT. So let me just do that as well on the DMZ to DNAT to DMZ. And on the translated packet we did not translated the source, but we can also do that. Let me just do it. Dynamic IP and port, and address type, use the interface address, and I will use the ethernet 1/2. Ethernet slash 2 is this one. It will use this IP address 50.50.1 this time. Okay, and IP address will be 50.50.1. That's fine. Hit OK and commit it. So what is going to happen now, that this time the request we will see on the server here, you see. So this time you will see that the destination will be 50.50.50.1. Means the request on the server will be coming from .1 IP address. It means that the actual IP of the source will be lost. What I mean here, like any request that is coming from this user from here to here. So normally if the request is coming to the server, he should be aware that what is the source IP address, and it should be 50.50.50.10. So that's why we do not translate the source, so that the server could be aware of that who is the actual requester, right? So if it is having a logging enabled, they can log on that who is the actual user of that one. But if you enable this source translation, what is going to happen, the request will be coming from this IP address. Means that the uh, it will request to here, It will be source and destination, both will be translated, then it will be coming to here. When it is replying back to this IP address. So it's like you are losing the some of the details that who is the actual requester. So, but if we can do it, so that's what I'm showing. But we just never use, and we always log the actual information on the server that who is the sender from the internet. All right, but I has configured it. So let's see that how is the request. Let me ping it from here once again. And the reply is coming from 50.50.100. That is fine, but on the server you see that the request is sent to 50.50.50.1. It means that server is never aware that who is the actual requester, but actual requester was 50.50.10. But here you see that for the server the destination is 50.50.50.1. So that is the problem, but still we can use it. All right, guys. So that was about the destination NAT. And if you have any question, feel free to ask me. And please also like you can reach like me on the Instagram and the LinkedIn. I think LinkedIn is better. You can reach me on the my professional LinkedIn with the name Anuj Bharadwaj. I will post the link or profile URL on my description. You can reach over there. All right. If you have any question, feel free to reach me. Till that, bye bye for the next session.